Hi everyone, this video is part of Macquarie University's coding tutorials, and today we'll be talking about class composition. We'll be discussing how one class can contain another class object and how this can be useful in creating more complex and flexible code. We'll be using the example of a line class and a point class to demonstrate this concept. First, let's create a point class. This class will have two instance variables, x and y, which represent the x and y coordinates of a point, and are ints for simplicity. We'll also create a constructor for the class which will take in two parameters, x and y, and initialize the instance variables with these values. Now let's create a line class. This class will have two instance variables, start and end, which are both of type point and represent the start and end of the line. We'll also create a constructor for the class, which will take in two point parameters, start and end, and these will be reference copied to this.start and this.end. Notice that whichever points get passed in to be the start and end of the line, we are not making instance copies of them. Instead, we are using the instances which already exist and make lines start and end refer to them. In this way, the line class is composed of the point class, because the line class has two instance variables of type point. Now let's create a line in our client code. We know that to have a line, we need 2 points, so let's create those first. Let's declare a point, calling it p for simplicity. Then we need to instantiate it to a new point, and let's make its x be 10 and y be 40. Let's declare a second point, calling it q. Then we need to instantiate it to a new point, and let's make its x be 70 and y be 60. Remember that we know that we're passing in the x value first, as that is what we defined in the constructor in the point class. Now let's create a line object, we'll call it line, and instantiate it to a new line, passing in p as the start and q as the end point. With the way we've made the point and line classes, there are no visual aspects of what is created. That is, when we run this client code, there is no actual points or lines graphically made. But in theory, we have simulated a line where the starting point is at coordinate 10, 40, and the end point is at 70, 60. Now let's see how this would translate to a memory diagram and how we can figure out how many references and instances there are in total. In the client code, we have created 2 point objects, p and q, which are stored in memory as separate instances of the point class. So let's first look at those points. We refer to p and q as point references that are pointing to different point instances. We can see the arrow goes out of the reference and to the instance, helping us more easily count the number of references and instances. Since the x and y of each of the points are ints, and therefore primitives, we can just write x equals 10, for example, and don't need any arrows. Then we created line, a line reference which points to a line instance that stores references to the start and end point objects. The start reference is pointing to the instance that p is pointing to, and the end reference is pointing to the instance that q is pointing to. This is an example of composition, where one class has an instance of another class. As you can see, the line object contains references to the point objects rather than creating new instances of the point class. One important concept to note is that the start and end references in the line instance are not pointing to the p and q references themselves, but to the instances p and q refer to. We never make a reference point to another reference. It must point to an instance of its type. If p.x changes, that will also change the start.x value, since they are currently referring to the same instance. But if p changes which instance it is referring to, that is, the arrow moves to some other point instance, start will not change and will continue pointing to the current instance. Counting how many references and instances are in the diagram in total, we can see we have these point references: the p point reference, the q point reference, the start point reference, the end point reference, and the line reference, totaling to 5 references. Notice that the number of arrows in the diagram is 5. This is a good indicator of how many references there are if we've drawn the diagram correctly. With respect to instances, we have the 2 point instances and the single line instance. Notice that these are the only 3 blocks that actually have an arrow pointing to them, so we can make the counting easier by noticing that wherever there is an arrow going out, there is a reference, and wherever there is an incoming arrow, there is an instance. Take a minute to pause this video and closely look at the diagram, ensuring all connections make sense to you with what we wrote in the client in mind. In this video, we've seen how class composition allows us to reuse code by creating classes that contain other class objects as attributes. We used the example of a line class composed of 2 point class objects to demonstrate this concept. Remember, class composition is a powerful tool that allows us to build more complex classes out of simpler building blocks, and also help us organize our code in a more modular way. To better understand composition, it's a good idea to try create something similar to what we've done and draw out the memory diagram. It definitely is a concept that takes a lot of practice. A good exercise could be to create a car class that has seats made from a seat class and wheels from a wheel class. Also, we can never have references point to another reference, but they can point to instances of a class with other references as attributes. In the next video, we'll take a look at traversal through an array of objects and how to deal with null objects. See you there!